All right, this is the final video for week 3. It's on the Tuskegee syphilis study. So you had a reading about it, and I also had you do an exercise. The first part of the exercise actually asked about your understanding of the scientific method. And the reason that's there is that everything we're doing in this course is about science in part. And so we need to have a clear understanding of what science is and what science is not in order to properly understand how science is being used well or badly here. Okay, so to start with, we're going to talk about the scientific method, and then I'm going to say a few more things about the Tuskegee syphilis study. Okay, there's a lot of disagreement about what the scientific method is, actually. It may have seemed fairly straightforward to you when you were taught it in middle school. And that's because there's a certain basic agreement that everyone has. So the scientific method is some kind of hypothesis testing. But exactly what that means, and whether, for instance, it's the same thing across all sciences, is a much more complicated issue. When I teach, I use something called the semantic view of theories. So this is a theory this is an approach to the scientific method that says science is fundamentally about modeling. You create models, and then you have hypotheses that connect those models to the world. And then when you test a hypothesis, you are testing the connection between a model and a world. Or rather, the world. So a model is all sorts of different things. Often, actually, physical scale models are used. So one of the things, when I go into detail about this, I talk about the discovery of the structure of human DNA, which was actually done just using a physical scale model. They're putting together pieces of metal to see that it formed a double helix shape. It was putting together a puzzle in this fairly literal way. We also use analog models all of the time. So when an animal is used as a model for a human, that is a part of the scientific method. That's a part of modeling. So people do studies on rats, and that is taken to be a model for human physiology. Theoretical models are the most common sort, really. So these are essentially worlds made up of words and symbols and math. And then there are computer simulation models. These are most famous in climate change. The important thing to see here is that a model is like a map. A model is something that represents the world, and it has a similar structure to the world it represents, just the way a map does. But a map simplifies, right? A map that captured all of the detail of the actual world would have to be actual size. It would be completely useless, right? Maps necessarily simplify. And there are social conventions that explain how you relate, for instance, a subway map to the actual world. And the point is that the map is not necessarily true or false, because in some ways it's always going to be false. But it's better or worse. It fits the world better or worse for different purposes. I'm emphasizing this because I think one of the most common kinds of mistakes in thinking out there is to confuse your image of the world for the world itself. The old slogan is, the map is not the territory. The map is not the world. This is sometimes captured by this famous Magritte painting called The Treachery of Images. Ceci n'est pas une pipe, the image says. This is not a pipe. And you're saying, yeah, it's a pipe. Looks like a pipe. It's not a pipe. It's a picture of a pipe. Often when we encounter images of the world or representations of the world, there are layer upon layer of representation between us and the actual world that we are not thinking about. And this is a source of mistake in thinking. So there's an old comic that I particularly enjoy called Understanding Comics that takes some time out to talk about the Magritte painting. So here it is. Our narrator, Scott McCloud, is talking about it, and he says, so you see, it looks like a pipe, but it's not a pipe. Well, but it's an image of a pipe. It's a painting of a pipe. And then he says, no, wait a minute. It's not a painting of a pipe. It is a drawing that I made of a painting of a pipe. And in fact, it's not one. There are on this page 10 copies of this image. So there are always layers of representation. And the whole time the narrator is speaking, he's not actually speaking. You have word balloons above his head. A randomized controlled experiment is the central idea in the scientific method. It is how we connect models of the world to the parts of the world they are taken to represent. A randomized controlled experiment is meant to test a causal hypothesis, a claim that one thing causes another. And you do this by creating two groups that only differ in that one has the possible cause and the other does not. Everything else about every other difference between the two groups has been randomized. So theoretically, there are going to be the same number of other causes in each group, and so they will cancel each other out. Now, you should be familiar with this, but I want to emphasize it because again and again what you see is people not really understanding how science works. You select a random sample from a population you want to study. Except sometimes it's not actually the population you want to study. Sometimes it is a representative, a model of it. For instance, you may have a random sample of rats when actually you want to study people. You randomly divide that sample into two groups, the experimental group and the control group. You introduce the cause to the control group, and then you measure the difference between the two groups. If you are engaged in ethical human experimentation, you should have what is called clinical equipoise. You should feel that no matter which group a person has been sorted into, they are equally well off, right? So if one group is getting no treatment and another group is getting a treatment, you should say, I know so little about this treatment, you might be better off not getting it at all. So this leads to an important mistake that people make. It's called the therapeutic misconception. This often comes up when people are enrolled in medical studies. They believe that the purpose of the trial is to benefit them rather than to gain knowledge. And they think in particular that because they have got access to this experimental treatment, they are better off than the people who are not getting access to the experimental treatment. But that is exactly not what is happening. The researchers have to believe that we don't know enough about the experimental treatment to know whether you are better off getting it or not. The point is not to help the patient directly. It is to gain knowledge while providing a certain minimum of care to the patient. So we talked about medicine in the slave era 2 videos ago. And again, I want to emphasize this. In the 19th century, all sorts of weird experiments were conducted on slaves in order to prove that they were biologically better off being slaves. And this produced a lot of pseudoscience. We also, in the previous video, talked about eugenics. Eugenics is the practice of improving the human gene pool. And until World War II, it was common for people of all political stripes to believe that the human gene pool should be improved through selective breeding. And in fact, there was a sudden U-turn after the Holocaust. And it's one of these amazing U-turns in the history of science. Suddenly, we went from a situation where everyone was a eugenicist to a situation where no one is a eugenicist. And that's because of the horror of the Nazi experiments. This is a theme we're going to keep returning to. We saw this when we were talking about the Belmont Report. The Nazi experiments introduced the idea that we need to hold medical experimenters to a high standard, but it actually takes a long time for that to really sink in practice. All right, so I want to talk in more detail about the timeline for the Tuskegee study. In the previous video, I gave you a bit of the prehistory, where there was a study that was done with patients not getting treatment, but that study ended as soon as the 606 treatment was available, because the 606 treatment was okay. 1932, nevertheless, it is decided that doctors will begin to follow patients, black patients who have syphilis, and we are simply going to observe the process of the disease and not treat these people even though we could. So by early 1940, the Alabama Health Department is operating a mobile venereal disease unit, and they are actually instructed not to treat the men in the survey, in the Tuskegee study, even though they could help, because the doctors who are doing the study want to see how the disease progresses. In 1941, World War II has started. The Army thinks it's pretty damn important to have soldiers that don't have venereal disease for obvious reasons. So the Army is very busy treating everyone they can with what treatments are available for syphilis. They are told not to treat these men so that the doctors can observe the progress of the disease. Penicillin is introduced about this time, and it's finally, by 1943, it is shown that syphilis can be completely cured with penicillin. 1947, the United States Public Health Service establishes rapid treatment centers across the nation so that patients with syphilis can be treated with penicillin. The men involved in the Tuskegee syphilis study are not treated. This just goes on and on. Remember, the study started in the 30s, and we're just still watching people die. In 1965, the Center for Disease Control has a conference where they discuss this study, and they decide that it's not racist that we're doing this, and the study should continue. 1965, a guy named Peter Buxton is hired by the U.S. Public Health Service. He's a social worker. He's also the son of Holocaust victims. And his job was to interview men with venereal disease, and he learns about the Tuskegee study. This is 1965. 1966, he files a formal complaint with the USPHS about the study. 68, he files another complaint. 69, the CDC holds another meeting and decides, very deliberately, not to end the study. Buxton then goes to the newspapers, and in 1972, Gene Heller runs a story in the evening edition of the Washington Star, and by the next year there are Senate hearings about this. So this is the original evening headline. As you can see, actually, a lot of people are concerned about the other things that were going on, the Vietnam War, but right there in the top left-hand corner, public health service study denied patients treatment. So this is the hero in our story, Peter Buxton. He's the whistleblower. He was brought to the U.S. as an infant fleeing Nazis. When he was 27 years old when he learned about the experiments. He said, "I didn't want to believe that this was the public health service. We didn't do things like that." This is actually a theme we're going to see repeatedly. It is the real change in medicine doesn't actually come immediately in the wake of the revelations of the Nazi atrocities. It's only in the 1960s when the children of the Holocaust, who have been told all their lives that this should never happen again, start discovering that things are happening again, that actual medical practice begins to change.